Hey everyone, this is the DevOps Lab. I'm Damian and I'm joined by a fellow Aussie, Troy Hunt. We see each other in different countries and very rarely in Australia, right?
Yeah, you may remember me from such conferences as NBC
exactly.
and all the other ones.
So we are in Seattle, in Redmond, for the MVP Summit. You're an MVP and Regional Director, right?
Yes. Yeah, I have the badge to prove it.
Badge to prove it, yep. Yeah. So Regional Director is like a super MVP, right?
So, yeah, some people describe it that way. I think the less self-ingratiating way of putting it is that the MVP award focuses on technology areas. So originally my MVP was developer security, now it's Visual Studio and tools, etc. The Regional Director tends to sort of be a higher abstraction and that it's not aligned to a given technology. But we sort of get a better overall view of the Microsoft strategy. Okay. So, you know, we'll be talking a lot about Azure things and where we're going with the cloud and other sort of platforms beyond just the tech itself.
Okay. So you started in security as an MVP, right? And most people would probably know you as the guy behind Have I Been Pwned? Yeah. I know you as the guy behind Have I Been Pwned, where I get emails fairly regularly telling me that my passwords are... Yeah. So that's fun. But anyway, one of the other services you added to Have I Been Pwned, or at least that family, is Pwned Passwords. All right? Tell me about that. What does that look like? How's that different?
So with Have I Been Pwned, that kicked off in late 2013, and the original premise of it was let's allow people to see if their email address was exposed in a data breach. Yep. So the only thing it's ever had in it was email addresses from data breaches. So, you know, there'd be like the whole breach, I'd just take the email address, put that in. And then one of the things that happened last year that was really important is NIST, National Institute of Standards Technology. They came out and said, hey, here's a whole bunch of guidance about how you should be doing authentication. And a lot of it sort of went against the grain of traditional thinking. So it was like, you probably shouldn't force people to change their password every 3 months because they're just going to put a number on the end and increment it. You know, like mind blown. One of the things they said is you should stop people from using passwords which have appeared in previous breach corpuses. Okay. And this was really important because they're saying that there is this thing called credential stuffing, which is someone takes an email address and password pair from one data breach and then they go and try it somewhere else.
Yeah, right.
The thing is though, NIST never said, like, here are the passwords not to use. They just said, you shouldn't use them. So in August of 2017, I went out and collated about 320 million passwords from different data breaches. I SHA-1 hashed them all, so there was some degree of pseudo-anonymization. And then without any association to the actual usernames, I put them in Have I Been Pwned, I allowed people to query them via an API, and I made them downloadable. So you could go and download 320 million SHA-1 hashes, put it in your system, and then when someone comes to log in, register, or change their password, you can SHA-1 hash what they give you and you can compare them.
So you can basically tell them whether that password has been breached before, whether it's been used in a breach, without exposing the password to them or anything like that.
That's right. And look, I mean, you can go through and crack them if you really want to, but frankly, you might as well go and find the same source data breaches that I have anyway. Right. So that it's a veneer of security insofar as I just don't make it readily reversible. Okay. But that would then be the premise, where someone can say that we're building a system. When someone comes to do one of those three things, well, particularly when they come to, say, register or change a password, we can say, this password has previously appeared in a data breach. Of course, you can also do that when they come to log in. You need a point where you can get it in plain text so that you can hash it and then compare it. Sure. And then it's up to the site to decide what to do. So they could say, it's been in a data breach, you just can't use it at all. They could say, it's been in a data breach, maybe you shouldn't use it, because there's a usability impact, right? If you say to people, we're now going to put a barrier to your entry, they might have just flagged the account. So no visual user warning whatsoever. They just go, hey, let's just put a little tick on a box. It's like an is pwned box or something like that.
Yeah, okay.
And then if we see suspicious activity later on, we can come back and identify that.
That makes sense. Okay. That's pretty cool. So people can download these hashes. Can they hit an API as well? Is that
they can, and I think what we've actually got to talk about for this to make sense is we've got to talk a little bit about Pwned Passwords version 2, because the August 2017 thing was version 1. Okay. In Feb of 2018, which is only about less than 2 weeks before our point of recording now, I put out version 2, and I expanded that to 500 million passwords, just over 500 million. And the other thing I did is I did this really, really neat anonymity implementation which Cloudflare came up with. So we're going to look at some Cloudflare stuff soon. I did a lot of work with Cloudflare on this, where they said, hey, what would be cool is that people could make requests to your API with a password, but you not know what it is. Okay. Now, you could do that in version 1 with a hash, but frankly, if I've got a SHA-1 hash of a password, most people use pretty bad passwords. You could take that, you could crack it, you could figure it out.
Yep, okay.
So they came up with this model where they said, well, what you do is someone creates a SHA-1 hash for a password, you take the first 5 characters of the SHA-1 hash, you throw that at like a range API, and then it comes back and it gives you every suffix, so the remaining sort of 35 characters of the 40 character SHA-1 hash.
Right.
And what you do is as the consumer of the service, you pull that back and you go, okay, now I'm going to take my entire hash and I'm going to see if that appears anywhere in the list. So on average, there's 478 hash suffixes for each one of the 5 character prefixes.
Okay. And there's enough passwords there and enough hashes that you're always going to get a collection of passwords, right?
Every single one of the 16 to the power of 5 possible different 00000 values through to FFFFF values, so it's just over 1 million different values, is populated.
Right.
And the smallest one is 370 odd suffixes, and then the largest one is 500 something. So average 478.
So this is like this anonymizes it, but it also means that you're not sending back the entire database every single time.
Yeah, correct. In fact, let's have a look at how that works, because if we jump into the dev tools here, we can actually see it in action. So if I searched for a terrible password, so let's just say password like this, and that is literally PASSWORD.
Okay, good.
We'll pop open the dev tools, network tab, let's do a search, and we'll have a look at what's actually sent. So we'll see that when we look at the name over here, we're just seeing 5 characters. And what we're actually looking at here is the first 5 characters of the SHA-1 hash of the word password. Now, just to sort of maybe put it in a little bit of context, if we go to SHA-1online.com and we enter password in plain text and asked it to create a hash of that, we'll see that the first 5 characters are BAAA6, which is exactly what we should see. Now there's other requests, but exactly what we should see in this first one.
Sure.
Now, the remaining characters are all of these guys just here. So we can take this, we can look at the response here, do a search, and there it is.
That's a lot of people using password as a
Well, yeah, actually, we should talk about that because we haven't touched on this. So one of the things that happened in V2 is I also added a count for how many times the password had been used. It has been used this many times, and if we scroll down a bit and look at the UI, we'll see that represented just here. So from the sort of the anonymity perspective, think about what this means. So all I know is my service has received this.
Yep.
Now in my database, I have all of these values, which are SHA-1 hashes, then in this case it's 466, that begin with those 5 characters, and then they end with the other 35 characters that are represented there.
Yep.
So when someone searches for that, as far as I know, it could be any one of those 466 values.
Sure.
Or it could be a whole bunch of other things I don't have in my database. And yes, it is more likely that it's going to be the one that was just here, because just statistically, people are going to reuse passwords, they're going to be terrible. So statistically it's going to be that. But if people are worried about that, then they can actually go and download the whole set as well. Right. So down a little bit further, you'll see there's some download links. You can download these 501 million passwords, either sorted by the prevalence or sorted by the hash, because some people said they didn't want it just sorted by prevalence, they wanted it to be anyhow.
Right, yeah, sure.
I just made it easy and I put it back there.
Okay. So this is interesting. What you actually have in your database is just the hashes and a count, is that right?
Yeah, exactly. So in fact, well, we'll talk about the internal structure in a moment, but yeah, for all intents and purposes, all I have is the full hash broken into a couple of parts and the count after that.
Okay. So this is what I'm interested in. You said there's, how many passwords are in this?
501 million.
501 million passwords.
Yeah.
Now I'm a kind of old school application dev thing. You know, I maybe put that in a SQL database. I used to want to do that kind of thing. That doesn't seem like it's going to be an efficient way of, you know, full text search. You just do the first 5 characters. That's going to probably take a while, right?
Like this is total sledgehammer nail sort of scenario. And
yeah.
I remember back to corporate life when I was like, you're in the enterprise, and every answer to the enterprise question of how we store data is a SQL server, and this is just what everyone always did.
Yeah.
And the reality of it now is that we've got a lot of other data constructs that we can work with, and different data constructs lend themselves better to doing certain things. Mm-hmm. So in Have I Been Pwned itself, in sort of the classic kind of email search feature, I've always had a combination of a relational database for very query-centric sort of storage requirements. Mm-hmm. So for example, when I load data, I need to be able to join on subscribers and then the email addresses and the new stuff, and sort of do SQL joins and conditions and ordering, relational database stuff. But I've also always had table storage to actually store the near 5 billion accounts that are actually in the Have I Been Pwned thing with the email addresses. And table storage in Azure has been awesome because it's been super, super fast to look up by key. So if you have a partition key and a row key, which is exactly what I do. I have the domain is the partition, and then every row has its own key, which is the alias of the email address. Yep. So it's been super fast to say, give me test@example.com. It's been super, super cheap to store those 5 billion records in table storage. It's a very, very cheap storage construct. And the other thing is that it's scaled in an absolutely linear fashion to the point where when I've had to think about scaling the SQL database or the app service it sits on, I've never, ever had to think about table storage.
Right.
So I've been kind of in love with table storage. So I decided when I did Pwned Passwords, I'd do the same thing. I would take all the passwords that are the hashes of the passwords, and I'll put them in table storage.
Yep.
And what I did, and I guess we're going to talk about the evolution here, what I did to begin with is I said, let's take the first 5 characters of that hash, so in this case that'll be these guys just here, and let's make that our partition key.
Okay.
Seems
to make sense.
Seems to make sense. And then what I'd do then is every one of these suffixes, all the way through to there, would be a row key. Mm-hmm. So then you've got like partitions and rows. Made it very easy to look up an individual one, because I could take a hash, get the first 5 characters, go, that's my partition, the last of it, here's my row.
Yep.
It also made it very easy to do this range search, because I could say, here's the first 5 characters, get me the entire partition. Sure. And then I just had one other column on that table, which is the number of occurrences, like that. Yep. So that seemed like a good idea at the time, because that's what I had always done with Have I Been Pwned. And I kind of had this light bulb moment a little while ago where I realised that I was falling into the same trap as I'd sort of lamented other people doing, in terms of, we have always used a SQL database, let's just do it. And I was doing the same thing with table storage. And the penny that dropped was that ultimately there's only like just over 1 million possible results here.
Yeah.
Right? So do I need to have, and also let's be clear, there's never going to be more than 1 million, because I've filled out every single possible character space of that hexadecimal zeros through to Fs. So do I need to do that, or could I put them in blobs? So if I put them in blobs and there was just like a file called 00000.txt, and then I had what we see here on the screen in there, would that be any faster?
This is very, very much focused on read speed, not write.
Yeah, no, that's very, very true. So the joy about reading versus writing, and obviously these are like pivotal decisions in choosing your data structure of choice, is that I create Pwned Passwords and I update it maybe once every 6 months, something like that. Yeah. So this is not going to change until I get a big enough collection of new passwords that have never been seen before for me to justify doing this. Right. And I just went 6 months without having to do that. So all I need to be able to do is to read this data as fast as possible, and I don't really care how long it takes to write, because I've got months to think about that.
Right. So one of this being the DevOps lab, one of the things we talk about in DevOps is delivering value to users, and value can be, it used to take 50 milliseconds to respond, and now it takes 10, for example. Right. That's still delivering value. So this was an attempt basically to do that. Right?
Yeah, well, you know what, let's actually get numbers, because I like actually having tangible metrics that we can look at.
Yeah.
And we're going to talk about a lot of value, if you like reducing times. I'm going to jump over to my Azure portal, and I've got App Insights running on this Azure function.
Yep.
So the first thing, actually, let's be clear about this. This request here hits an HTTP triggered Azure function.
Okay.
So this particular host name maps through to the Azure function. When you hit range, it is literally a function which says, give me 5 characters. There's a little regex that says it must be, basically 5 characters of hexadecimal.
Yep.
That's fine. Takes that, hits the function, and then the function talks to the storage. And I've got App Insights running on the function. And what we're seeing here is the last 24 hours of performance. But you'll sort of see that there's a bit of a drop here.
Yeah.
Okay, going back almost a day. But I want to go back further than that because I want to talk about an even bigger drop, and then we'll talk about this last drop. So I'm going to go back to about 30 days worth of data.
Oh, wow.
And we'll see a few things here. So first of all, we'll see under our operation names, these are all the different functions that have been running over the period of that 30 days. Now, there's one highlighted down towards the bottom, which is range get. And we can see that next to that, that's been hit 2.86 million times. That's the big one. That's the one which does the search that we just saw.
Yep.
Now, there's also password get underneath that, which is the ability to get just a single hash out of the database. Frankly, I want to kill that off.
Yeah.
I don't, you know, I used to do that with V1, but now I'm like, there's not really a point because the range thing works so well, and we'll come back to the performance benefits in a moment too. And I just noticed I've got a few other things here. I've got k-anonymity get and post, and I've also got password post. I used to support other verbs. I used to call range k-anonymity, and then I changed the name before I went live. So we've still got some old stuff in App Insights here. Here's the important thing though. If we go back and we look at the performance around about this period just here, it was all sort of 360 odd millisecond stuff. Then I launched it. Now this is the point where I launched because we can see the green graph beneath it starts to really ramp up. This is volume. And we're all around sort of, what was that, about 112 milliseconds just there?
Yep.
So this is sort of the point where it went out to the masses and everyone started hitting it. And then I realized that we could actually make things a lot better. So you'll notice, in fact we can click on that, 121 milliseconds in that sort of area. You'll notice that around here, suddenly everything starts to get really fast.
Yeah,
okay,
right.
so now we're down 54, 58 milliseconds. Like things have actually gotten a lot better. And if I put this down towards more of a, let's go maybe the last 7 days, we should see some of these are even a little bit far. Oh yeah, actually around about there, 50, 60. Sometimes it's a little bit slower. And also note how it sort of maps to the volume. It seems like when there's high volumes coming through, stuff stays warmer.
Yeah.
Just responds quicker.
Yeah.
Maybe it caches a little bit on the back end as well. Main thing here is that what we're seeing now with that sort of 50 milliseconds rather than the 120 odd milliseconds is pulling from a blob as opposed to pulling from table storage.
Right, so even just doing that.
Yeah, so this is exactly the same data, didn't change the API signature at all. Externally, the only thing people know is it's like, hey, it's running 70 milliseconds or something faster than what it was before.
Right.
But I found this was really fascinating because, in my mind, table storage rocks and it's super fast and it's the thing to do to query. And then I realized that query is really just saying, like, just get me this file with these results.
Yep.
So it could have been blob.
So now that basically just maps to a straight get of a file, dumps that file out to the browser, and it's twice as fast.
Yep, exactly. So there is literally a container in storage with a blob that just has 1 million something records that are like, all the zeros.txt through to all the f's.txt.
So interesting as well. What does this do to your costs? Is it comparable to doing the same thing with functions, or do you know those?
Well, keep in mind the function's still there because the function is still the handler that receives the request and then it goes to the storage construct. But instead of going to table storage, it's now going to blob storage.
Yeah.
It should reduce the cost because I should just now be paying like, well, in fact, I'm not even paying blob egress because it's not egressing. It's still egressing from the function, if you like.
Yeah.
So it shouldn't really change the data cost, but it should change the number of transactions that would have hit table storage, which you pay for, which now no longer don't. And then I'm really just up for the storage cost in blob storage, and there's about 30 gigabytes of data or something there, so the storage cost is just about nothing.
Interesting.
But there's two other things I want to show you.
Yep.
Probably more than two. We'll see how carried away we get. If I go to the last 24 hours, because I haven't already had enough stuff to do or at the MVP Summit, this is when we've seen stuff really start to dip again. So we got like 120 odd milliseconds with table, down to 63 milliseconds with the blob. And then, now I'm down here. And I'm really happy with this.
So you've halved it once, and now you're what? That's a third of the speed now.
So here's the magic in this, and I've got to give credit to some random Twitter person for this as well, because they said, when you're reading the blob, make sure you're not just reading it out as a string. You can actually read it out as a binary stream and just pass that binary stream down to the response.
Okay.
And that's this change. Like, it was literally just a few lines, and the penny just didn't drop at the time that there was a more efficient way of doing it. But basically, I made this one little change. This is what I could do at the summit. Yeah. One little change, pushed it back out, and now we're dropping down to these sort of times.
Right. That's very cool. So this is just like small changes that you've made, but especially because of the volume, this makes a massive difference.
Well, it does. So if we look at this based on the last 12 hours, so it's just all going to be the new model, our average execution time now is 18.7 milliseconds. It's been hit 60,000 times just in the last 12 hours, which is sort of an important volume. The interesting thing too is when we look over here and we look at the distribution, we're seeing 50% of requests being served within 7 milliseconds.
Yeah.
So, you know, there's a good chance you're going to get this thing in less than 7 milliseconds, which is super fast, which is important for functions, because functions you will pay for based on both the number of executions, so that hasn't changed, but the duration.
Right.
So if I can get these running at sort of 7 milliseconds, which is the 50th percentile there, instead of 120 like before, that's just absolutely slashed the cost of this.
Right. That's very cool. You mentioned that there was something else you were going to show as well.
Yeah.
And you've talked to me about this before.
All right, so here's a pro tip. The best way to save money on Azure is not to have requests hit Azure.
So this is like the good old best way to win a fight is to not get into a fight.
In a way, but you still get the pleasure of winning the fight, right? So this is what we're doing next. So let me show you a couple of things. We'll show it in the UI first, and then I'll show you some more graphs, because everyone loves graphs.
Yeah, sure.
So when I made this request, if we have a look down here, we'll see we've got a response here that says CF cache status hit.
Okay.
Now, this is a Cloudflare header. So I've got Cloudflare wrapping around all my Azure things. Every single thing I stand out on the web today, Cloudflare wraps around. And it does a whole bunch of awesome stuff. So it can do things like block a bunch of automated attacks. It has built-in web application firewall, a lot of DDoS defenses. It can also do a huge amount of caching.
Right.
Now this is really cool, because I have my cache control headers here. I have a max age of about 1 month's worth of seconds.
Okay.
So when that function responds, the function adds this cache control header. It says, look, anything downstream of this for about the next month caching. If I'm going to update my Pwned Passwords in the future, I need to start thinking about it within a month of doing it, and possibly backing that expiration off, so that people do actually get the change. But for now, it's got a month. Now what it means is when Cloudflare wraps around it, they've got 122 edge nodes around the world. In fact, it's cool when you sort of see the, let's take that out of there. We'll go to the home page. Cool when you see the map. So they've got, 123, it's gone up since last week. Every one of those little dots is a Cloudflare edge node. So when you make a request to Pwned Passwords, or the Have I Been Pwned site, or TroyHunt.com, you hit one of these little dots. And these little dots all the way around the world are caching this response. So when I go and look at my stats now, what we're seeing here is how many requests actually hit the cache versus hit the origin. So if we look at the last 24 hours here, we've had 435,000 requests, 312,000 of them been served from cache. So we're sort of at roughly about 3/4 of requests haven't even gone all the way to Azure. It's just Cloudflare going, yep, here you go, here's your response.
Wow. So in your case, this reduces your Azure cost, I guess, by 3/4.
So this is wins all over the place, because every one of those 312,000 requests got served by Cloudflare, and they didn't go to Azure, and they didn't hit my function, and I didn't have to pay for it. So I win. The other thing is it's ridiculously fast as well, because you're literally hitting one of these little dots, and there's a dot next to you, no matter where you are, there's a dot next to you. So you're hitting one of these, unless you're in the middle of Australia. But everywhere else there is.
You've got other problems.
You've got other issues if you're there. So you're hitting one of these little 123 dots, and that's what's actually bringing back that super fast response time.
Wow, that's very cool. So I'm impressed by the fact that this is like win-win for the people using your site. So you're doing the whole delivering value to the end users, but it's a win for you as well, because you're reducing your own costs. Has this taken a lot of time to kind of get to this point?
Well, it's yes and no. So it's taken a lot of years of running Have I Been Pwned to sort of, I guess, think about where the optimizations are. Yeah. And it's taken a lot of years of using Cloudflare and Anger as well to think about how I can use that more effectively too.
Yeah. So these are like little tweaks that you've made that have had huge impacts. It seems like that's where you're getting most of your benefit, is just these small things that just have a huge impact, especially at this kind of scale. Are there other ones? I mean, you've hit 3 already.
Yeah, let's hit 2 others. So, in fact, this will be interesting because I don't know if this is turned on yet. There's a speed feature here within Cloudflare, and we can go down and turn on things like Brotli compression. Now, Brotli compression is kind of cool. So most people understand HTTP compression, that you've got gzip if you send the fact that you will accept gzip encoding in your request header and the server supports it, will send it back. Brotli is a more efficient compression mechanism that, depending on your content type, can compress it anywhere from single-digit percentages through to 30% better than gzip.
Right.
And it's a toggle, and you just touch the toggle, and then Cloudflare will automatically compress it.
Okay.
Now, they're meant to turn this on today for content types of text plain. They've had it on for content types of text HTML for ages. I honestly haven't checked to see if it works. Let's actually do this. So let's go and we'll clear our log just here. We might go through and tell you what, let's try this. What password do you use at the moment?
I'm probably not going to tell you that. I came prepared. I knew I was interviewing him, and I came prepared for this.
I'll tell you what, let's just try something else.
Don't tell Troy the password.
Don't tell Troy the password. There goes my social engineering fail.
Well. And there's another fail.
We can leave that in. I think I know why it's happening. I have got this really funky caching thing at the moment, where when the browser caches it, sometimes it ends up throwing this cause exception, which is kind of strange. Yeah, see? Because I do have cause enabled. So what we do is we go into an incognito window and we go to Have I Been Pwned, and we go to here and we go, I know how to make this work. All right, DevTools, network tab, terrible password again.
It's the same one you read from my mind, probably?
No, not that one.
Okay.
All right, so there's a few things here. Let's skip to the request headers first. When your browser sends a request at the moment for any HTTP resource, in your accept encoding, you'll have gzip. You'll find you've also got BR, and BR is the Brotli compression.
Yeah.
So what we're interested in seeing is if Brotli is enabled for that API yet. And I'm not sure if it will be. Hey, it is. It's turned on. Awesome. So now we've got Brotli. That wasn't there this morning. I literally checked it a few hours ago and it wasn't there. So I will be really curious now to go and do the numbers to see how much smaller this request is. And of course, we could always just construct our own request in Fiddler or something like that, drop the BR, accept encoding from the request, and let it come back with gzip, and then compare the two.
Okay, yeah.
But that's awesome, because that's a really good example of one of those super simple little gains where it's like, just turn the switch on.
Yeah.
Oh, also, interesting thing, you can only get Brotli with HTTPS as well. So if you needed another reason to go to HTTPS,
yeah. I hear that's a bit of a pet project, trying to get everything on HTTPS.
Oh man, we're saving the world. We're saving the world going to HTTPS.
Awesome. So that's Brotli compression.
Yeah.
Was there another one?
Yeah. So one more thing, and this is a really interesting thing. I'm going to actually scroll to the blog post I wrote about how I was getting faster and faster and faster.
Yeah, we'll put that in the show notes as well.
Sweet, okay. So we'll put that in the notes. I've got a bit here on Argo. Now, let me explain how Argo works. At the moment, when you make a request from your browser to a website, you basically don't have any control over which way the traffic goes.
Right.
Like we know in our sort of very high level innate geek brains that there are lots of nodes and the traffic will go between lots of nodes and it's probably going to go the fastest way, but how does it decide which way to go?
Yep.
You could have congestion at certain nodes, you could have unreliability at certain nodes. It may be that the fastest way is actually the long way around.
Okay.
So Cloudflare's Argo implementation has this neat little, first of all, animated GIF that explains it. So it sort of says, hey, look, there's like a really direct route here from somewhere on the west coast of the US, in this case, to somewhere over in China, for example. That direct route may actually not be very fast. What if we go around like the congestion avoidance route and we go through South America and then we go to Africa and then we go to India? And, right? So I've got a screen cap here of what I've found Argo doing for the Have I Been Pwned Passwords. And what we're seeing here is that when I didn't have Argo enabled, there was a round trip cost of 706 milliseconds. So that's between the Cloudflare edge nodes and that Azure function. When I turned it on and it started like dodging around all the congestion, etc., it took 60% of the load time off, so we're down to 278 milliseconds.
So another like third off, or another two-thirds off.
Well, it's another two-thirds off.
Yeah.
Now, again, this is only if it's not served by cache, right? So I'd rather it's served by cache and not even have to figure its way around the world. If it does, then it can take a huge amount of traffic off. And the biggest difference it made is on this graph down here. It's like, if you're particularly in Austria, you win big from this.
It's fascinating.
So because my Azure functions run in the West US data center, which is a long way from Europe, it gets a lot of advantage out of Argo and being able to route around all the congestion and everything. And it's just a toggle. You just turn it on, magic happens.
So you've got, this is like 5 different small improvements to various things that have had huge, huge impacts. Benefits the customer, obviously, because things are faster. And in most cases, benefits you because your service is faster. And in some cases, costs less as a result.
Yeah, exactly.
Have you got plans for what's next?
So what I'd really like to do is I'd like to go back to this graph that I had back here about the amount of content that's being cached, and I would like to get that orange bar as high as possible and the blue bar as low as possible.
Right.
So there's discussions I'm having with Cloudflare around cache eviction. So I've got just over 1 million different possible endpoints that could be hit. How can I make sure that they stay in cache for that like 30 days? And they only drop off after the 30 days, instead of at the moment where if some of them get stale, they're dropping off earlier because their resources need to make way for other things, education and this sort of thing.
Okay, so that's another potential point of
and you know, it's almost like the best motto of this is it's like the most efficient way to make Azure awesome is to stop hitting Azure in the first place, like hit stuff upstream, and then only pass through what you have to, and then make Azure as awesome as possible by using the right data construct.
Right, that's very cool. Look, thanks so much for showing us this. This is kind of a side of large-scale sites that you don't really see a lot of the time. I know none of my stuff is big enough to get hit that often, so it's good to see something at this volume and the small changes that can be made to improve performance. Yeah,
well, hey, I'm going to keep writing about it too, because I honestly, there's the geek in me that really enjoys doing this, and people seem to like reading about it as well.
Yeah, definitely. Awesome. Well, thanks for showing us.
Thanks, mate.
Thanks everyone for joining us, and stay tuned for another DevOps Lab sometime soon.